In this video, we're going to be looking at failure modes and failure effects within Express. There are two main reasons for adding failure modes to an Express model. The first is when we want to test for specific ways in which a system can fail. In this case, we'd add or import failure modes into the model and then create tests with coverage defined in terms of those failure modes. The second reason why we might want to add failure modes to our design is when we are performing FMICA analysis within Express. Since failure modes are the lowest level building blocks of the Express FMICA, we would definitely want to add or import them into our model. To complete the data needed for the FMICA, we would then add or import failure effects that represent the ways that failures manifest themselves at different levels of the design. Before we look at failure modes and effects in the Express interface, let's briefly discuss the ways in which failure modes and effects are related within an Express model. In Express, we always start by modeling failure modes on our lowest level components. For each component, the failure modes represent the different ways in which that component can fail. We then add failure effects that represent the immediate effects of those failure modes upon that particular component. We call these object failure effects, or object effects, because they are stored on the object and represent the manifestation of these failure modes on the object itself. We do this for all components in that level of the design. We model the different failure modes and then the object failure effects that represent the impact of those failure modes upon those objects. We would next create a set of failure effects that represent the impact of these object failures upon the model as a whole. That is, upon the design level that is represented by that Express model. We call these effects design failure effects or design effects because they represent failures to that level of the design hierarchy. For each design effect, the different object effects that can result in that design effect are listed as causes. Now imagine that we are looking at this model from the next higher level in our design hierarchy, in which an object or assembly is linked to this lower level model. The design effects from the lower level design are automatically inherited into the upper level design, where they become object effects on the upper level assembly. So if this upper level assembly were to represent, say, an LRU, we see that the local design effects in the lower level model are equivalent to the object effects of that LRU. Assumedly, this upper level model would have other LRUs, as well as perhaps some additional non-hierarchical components, and all of these would have failure effects on them as well, either inherited from below or directly modeled on the object. So within this upper level model, let's call it a subsystem model, we then create design effects that represent the manifestation of the various LRU failures within this particular subsystem. And if we were generating a FMICA chart, these design effects would constitute our local effects if we were creating an LRU level FMICA, or our next higher effects if we were doing a piece part or component level FMICA, in which case the local effects would be the lower level design effects. Of course, our system is likely to contain multiple subsystems. Once again, the lower level design effects are automatically inherited as object effects in the upper level design. So in other words, all of the design failure effects from the various subsystem models appear as object effects on the corresponding subsystem assemblies within the system level design. The last step is to model the effects of these failures upon the system as a whole. The resulting top level design effects will be called out as end item effects within any FMICA chart developed within Express. As we shall see in a little bit, a severity value is associated with each failure effect. These effects can be used within Express to optimize diagnostics by failure criticality, define severity-based subsets, or within a stage simulation to track critical failures over time. So to review, we begin by creating our lowest level failure modes and mapping them to object effects. From that point forward, we create only the design effects that represent the manifestation of these failures at each level. These design effects automatically become object effects at the next level up, so the analyst only needs to worry about defining the relationships between design effects and their object effect causes. This process is repeated until we've added design effects within our top level model. So now let's take a look at how failure modes and effects appear within the Express tool. When we model failure modes in Express, we start at the bottom, so we're going to descend down into this break assembly. Failure modes are modeled in the lowest level components, and they represent ways in which those components can fail. And when we create a failure mode, we type in the name of the failure mode and the percentage of the item's failures that are caused by this failure mode. Now, although all of this can be done by hand within Express, most analysts import failure modes from an external FMICA from a company database. Often, both failure modes and effects are imported from an Excel spreadsheet. But in addition to that, we also map which functions on an object are impacted by this failure mode. There's only one function defined for this caliper, so let's click on this valve. And here notice we have 4 different functions, and in this case, each one of these different failure modes can impact any of these functions. Now, once we've modeled our failure modes, there are a couple different things we can do with them. One is we can use them to change our test coverage so it's looking for a specific failure rather than trying to prove something is working properly. So we may include failure modes in our design only for the reason of being able to test for failures. The other thing we can use failure modes for are building blocks for our Famika. As we saw earlier in this video, failure modes map to failure effects which themselves propagate upward and create the lattice of ways in which failures manifest themselves at different levels. So once we have a failure mode modeled, the next step is to model the failure effects. Again, these can also be imported from a Famika. If we look at the failure effects for this piston, we can see that we have a hydraulic leak, and then there's a causes panel here. And we can see the hydraulic leak is caused by the hydraulic leak failure mode on this object. And loss of release pressure is caused by the failure mode loss of release pressure. On the objects, we often do a 1-for-1 mapping between failure modes and effects for the object itself, representing the way in which that failure mode manifests itself on that part. Now, in mapping our design effects, we can click on the background of the design and get a design failure effects panel. We can see we have 4 effects for this design, and their causes are the combined effects of the different objects. So we can have a hydraulic leak due to a hydraulic leak on our inlet or outlet valve, or on either of the pistons. And we can have a loss of braking for a whole variety of reasons, as you can see here. So what we've basically done is said that all of these different ways in which these parts in the braking assembly can fail result in only 4 main ways in which the brake assembly as a whole fails. Now, these design failure effects, when viewed at the next level up, become object effects of the assembly that links to this design. So we had 4 design effects here. And if we look at the failure effects of one of the brake assemblies, we can see that those same 4 design effects from below became object effects at this level. And that's true for all 4 of these since they all link to the same brake assembly. Now it lists that they are hierarchical causes because all of the causes are inherited from below. The next step would be at this level. For the individual components, we'd model the failure modes and failure effects on these non-hierarchical parts, so that we're having the failure modes and effects at this level as well. Then we'd create the design effects for this entire design. Again, if you click on the background of a design, we get to see the design effects. This particular design has quite a few different effects modeled here, but one of the more inclusive ones is unable to brake, which as we can see has a lot of causes to it. Unable to use diagnostics, on the other hand, represents only problems with the diagnostic connector or the electronic control unit. So what we're doing here is by creating these design effects at the top level, we're representing the way in which the lower level failures manifest themselves on the system as a whole. Once all of our failure modes and failure effects are in place, we're now ready to develop a Famika in Express.